In this video tutorial, we will explain how to measure solubility with the crystalline instrument by making use of the information from the captured images. Start your experiment by clicking on the new Crystalline experiment tile. Fill out the information for your experiment, such as experiment name, username, and description. Ensure that particle viewer and image analysis are on. Select the cap type and fill out the sample details such as compound, solvent, concentration, and the type of stirrer used. Next, construct your experiment using the tiles in the Program tab. First, add a linear ramp tile to the experiment. Here you can heat to 5 degrees Celsius below the boiling point of the solvent, at a rate of 0.1 to 0.5 degrees Celsius per minute, and with stirring of 800 to 1150 rotations per minute. Next, add the whole tile to keep the experiment at the top temperature for 5 minutes to allow for equilibration. Then add another linear ramp tile to cool down at the same rate as your heating step. Your experiment is now almost ready to be run. Before you run the experiment, ensure your camera is in focus for your sample. Please check the tutorial on how to adjust the cameras on the Crystalline instrument for more details. You can find the link to it in the description. To run the experiment, go to the Run and Results tab. Select the reactor. Then press play to start. The Crystalline instrument uses particle detection to determine solubility. After the experiment is completed, move to the Analysis section and select the Transition Points tab. In this tab you can see two blue lines. The first line is light blue and measures the transmissivity of the sample. This sample is copper sulfate, so the LED light is absorbed and gives a reading of 0% throughout the experiment. The second line is dark blue and refers to the particles detected. The number of particles detected is collected from the images captured by the Crystalline cameras. For samples where transmissivity is not suitable, we would use the information from the images to see the number of particles. In this experiment graph, we can see a decrease in particles detected as the sample is dissolved. After the solids are dissolved, you can see the background noise of the sample. Finally, you can see the increase in particle count when crystallization occurs. Next, click on the Settings button, where you can select the method for detecting clear points and cloud points. We want to select the number of particles, because this is the method where you use information from the Crystalline's captured images to determine solubility, instead of using transmissivity information to determine solubility. As a standard, the number of particles are set at 10 particles per microliter. Then, click Find All Transition Points to reanalyze the data. This will find the approximate area for clear and cloud points, which then needs to be fine-tuned. By clicking the pin, you can see the image taken at that specific time point and move it. Move the clear point pin until you find the last image where crystals are seen. Then, move the cloud point pin until you find the first image where crystals are seen. Data can then be combined in the Multi-Analysis tab to create a solubility curve. The Multi-Analysis tab is where you can combine and visualize multiple experiments into a single graph. To do so, first create a new multi-analysis file or open an existing multi-analysis file. Fill in the required details such as analysis name, description, username, and any comments you want to make. Then load the different experiment files you want to combine by clicking Add Experiment and adding the files. You can delete the files by using the Delete Selected button. You should reload any of the individual experiment files if the clear or cloud points in those files have been changed. In the Analysis tab, we now see the combined graph. You can fit the data using linear, quadratic or Van 't Hoff equations. Change the color of the curve by clicking on it and selecting the desired color from the spectrum. Individual data points can be excluded from the graph using the Exclude button. The line fit and values will then update to exclude the points selected. You can create a report as either a Word or PDF document using the Report function. Finally, you can save your project by going to the File tab and click on Save and Close. Thank you for watching. If you have any questions, please reach out to us.